Hello and welcome to the Dustin and Eric podcast show brought to you by Mimosa Networks. Hi, I'm Eric.
And I'm Dustin.
And today we're on episode number 20, DFS. Advice on duty-free shopping and how to get the best deals at the airport.
That's muy importante when you're at the terminal.
I think that we're actually talking about
DFS.
Dynamic frequency selection.
Yes.
But,
Let's do that instead.
All right. So today's not special guest is Jeff Jones.
Hello.
You've seen him before. He is special guest.
No,
special.
he says he's not a special guest anymore. So
I am with the woodwork.
He's
furniture.
more of a full-time member of this cast, I think.
Yeah.
Pretty much.
The Dustin, Eric, and Jeff podcast show.
Keeping up with the
DDJ.
Joneses.
All right, so we'll move right into today's main course, DFS, Dynamic Frequency Selection, and why you need to respect DFS on wireless links, 5 gig, 11 gig. So let's get right into it. So what is Dynamic Frequency Selection, and why is it important to us?
So it's part of spectrum sharing, primarily in the 5 gig, because the wireless LANs need to coexist with qualifying radar signals.
So what kind of radar signals are we talking about?
Yeah, what kind of radar-specific signal?
Well, it can be weather, it can be
radio, Doppler.
navigation, it can be military, it can be aeronautical. I guess that's
any kind of
part of...
and these could be different widths, these could be different signals, timings, all kinds of stuff,
Sure.
right?
So if radar and RF are unfamiliar to you, which hopefully you're familiar with both if you're watching the show, DFS may sound like a silly requirement at first. The reality is DFS serves a very important purpose because 802.11 wireless APs or any RF emitters have an immense negative impact on our radar systems, which I'll show you in a few minutes. It's true that radar systems blast out signals on the scale of megawatts, but their strength in sending radio signals out is mirrored on the receiving side. Because of high-gain antennas on radars, they can hear and see RF disruptions at a great distance. You may be thinking, really? How many businesses are near radar? And probably telling yourself, not many. The definition of near is complex. Standards define a few miles as being in very close proximity, and DFS documents reference specific requirements for anything within 35 kilometers or 21 miles of Doppler radar, TDWR, locations. Radar systems protected by the DFS standard come in many forms, including radar on boats, which we just kind of talked about, radars for TV weather stations, military radar, airports, and things like that. So in just the United States, there are 45 operational TDWR stations, terminal Doppler weather radar. These are the ones that are scanning for storms and stuff that pop up in the U.S. But when people transmit on TDWR, which is 5600, illegally, then you're picking up, or the weather radar is picking up your interference as weather, as rain or storms. For those of you watching from home, here's an example of one down in, I believe it's around Australia, New Zealand area, where you can definitely tell that that's a radar signal or somebody on the radar signal using a wireless radio to transmit across the water there. So that's showing up as interference on their radar scanning system.
I see. See the yellow. It has the characteristics of the scatter, the water and scatter and precipitation as it's seen off coast in the yellow over here. So it's kind of very similar.
Right. And there's almost 20,000 airports in the U.S. alone. So if you're transmitting illegally on a DFS band, you have a risk of causing air traffic control interference of some kind. People picking up planes or interference they think might be planes, and causes chaos and confusion at the tower. You definitely don't want to do that. So in the U.S., there's more spectrum available that is non-DFS than there is in Europe. So Europe is mainly, or at least ETSI regulations are mainly just DFS. So they have much lower transmit powers than what we can do here in the U.S. But when you're in a DFS channel, max TX power is 24 dB in our radios. I believe that ERP is max of 30 in the DFS channel. Is that right?
Mm-hmm.
In Europe, I am not sure. I think it's probably the same thing.
Yeah, it's really dependent upon the country and their regulations per country.
So what's the law on this? I've got a note here. By law, any and all 5 gigahertz radios must have the ability to detect radar signals as well as to automatically vacate the existing channel immediately.
Right.
So if they detect that, they've got to move off right away.
So what do our radios do?
Right. So ours will listen for 60 seconds. There's a 60-second listening period, and then before any link association, and then they'll go back. Or if a qualifying radar signal is found, the radio will vacate for 30 minutes. So I guess it looks like they'll listen for 60. If they find a credible radar signal, they'll move off. Right.
Within 10 seconds, yeah.
Right, within 10 seconds. And then in Europe is similar or different? Theirs is like 10 minutes in Europe or something. Don't they?
Yeah, I'm not really sure on Europe.
Okay.
So what are the frequencies that are used by radar and weather radar? Where in the 5 gig band does it start and where does it stop?
Right. I've got a note. Let's see, public safety. 4.9 down in public safety and up. I need the chart. You got the chart up?
I can get to the chart.
What are the parts of the spectrum?
It's a quiz. I'm just trying to see if you know.
I'll tell you which radios we have, and then when we get to the public safety part of it.
So I believe it's 5250 all the way up to 5725.
5250.
Yep. And it really depends on the size of the channel that you're
Right.
occupying as well. So.
And there's also some exclusions or restrictions in the middle of that band that you can't use at all, which at 5350 to 5470 is completely locked out. And then 5600 will be locked out if you're near a TDWR station.
That's right. Yeah.
So if you're using a Mimosa radio that has GPS, that'll lock that automatically. If you're using one that doesn't, there will be a lock in there initially until you actually put your correct GPS coordinates in there. So that's one way to know that you're in a TDWR zone. You can use our design tool, and you can actually enable TDWR radar stations and see those on the map as well. We've had plenty of people come in the chat in the past going, why can't I use this spectrum, or why does it keep pushing me out of this channel? Well, it's because you're too close to a TDWR weather station, and we certainly don't want you to get fined, and we certainly don't want to get fined from the FCC.
Right.
So here's an example of our spectrum graph from a 5 gig radio. So in the U.S., you can see the restrictions in red from 49 to 5150. And then you've got another restrictions from 5350 to 5470. And then you've got a gray exclusion there for 5600, which is the TDWR. If we put GPS coordinates in this particular radio, it'd probably go away. But again, if you're anywhere near one, it's going to stay.
Yeah, so that exclusion area, you cannot even select it if it's detected a radar. 5600 to 5680 is traditionally what time Doppler radar frequency in the United States. So you're not going to be able to select that frequency, so you're actually locked out purposely.
Right. So I know that there have been people who've come to chat before who say, my other vendor will allow me to operate in these channels, or they will let me operate at full power. Why don't you do that? Why can they do that when you can't? I don't know if I have a good answer for that, but maybe one of you guys do.
Well, I think one of it has to do with the leniency or the restrictions that manufacturer has placed on the spectrum. I know that there's some vendors out there that give the operator the ability to turn off or turn on those restrictions. Mimosa is elected to be more strict in that respect to ensure that we meet the FCC requirements and locking out that frequency if there's, by chance, in this case here, a detected TDWR signal.
Right. So if you guys have been around the WISP industry for a long time, you will know that people who transmit in frequencies that are restricted, the ones that have gotten caught by the FCC, has caused issues for the rest of the WISP operators. So that's why we at Mimosa again, have elected to close those frequencies off for those guys because we didn't want to even give you the opportunity to transmit in those frequencies because we want to try and stay on good terms with the FCC and those involved with those frequencies.
Absolutely.
Compliance right off the gate.
I know a few years ago we had a customer who literally had a knock and notice from the FCC where they were transmitting in a DFS frequency and they were actually interfering with the local airport, and literally FCC came to their door and had a cease and desist order in their hand saying, okay, you need to stop whatever you're doing here because you're literally affecting aeronautical radar. So they do that. It's not a urban legend, but in fact FCC will contact you and show up in person. So you don't want that experience because there's a fine involved at that point.
Right. So the next few slides here, for those of you watching, for those of you listening, it's just information on channels that are open or not open and how open these channels are. It's a page on Wikipedia about WLAN channel allocation in the U.S., Canada, Europe, and all around the world. So in this particular one, we have U.S., Canada, and Europe on here. You can see that it shows you the different channel sizes available and the channels itself available for use. So I'm going to scroll through these slowly, so if you guys are watching, you can pause and kind of look at it, or you can just go to the Wikipedia page and look at these as well. But you can see where Canada and Europe are a lot stricter on their spectrum than we are, and they have a lot less to work with as well. All right, guys, do you have anything else you want to add on DFS? I know it's extremely common for chats. I know that's why we're doing this show. So if we haven't covered something, feel free to throw it in there real quick.
Yeah, I think the one thing I would say is we see a lot of customers that may have unreasonable expectations about DFS. And if you always remember that you're the secondary operator in that spectrum, and that you, by law, have to vacate that channel within 10 seconds of a radar hit, and you build that expectation into using that frequency, for lack of better terms, then I think everything will be okay. It's the folks that don't understand DFS that are trying to support a WISP channel or a WISP backhaul, and the frequencies change on them and they lose their link. So, get yourself well familiar with the DFS usage in your area. Make sure that if you're near an airport, a military installation, or a time Doppler weather radar, that you build that expectation in that there's a fair to good chance that you may be reselected and lose that channel. So I think that's important to understand.
Right. And another thing here that I just thought of is if you're in a DFS channel and your antenna gain is set to 0, that makes your radio extra sensitive to DFS radar pulses. So if you're having what we call false DFS hits, it probably means that you're set to 0 antenna gain, which just makes your receiver way more sensitive than it needs to be.
How about the folks trying to move up in frequency, try to get to, say, 6,200 or 6,400 with some of the radios? They want to get out, they want to go higher, but they're using the same antennas that maybe have a slope or limited frequency operating. That might cut off at 5,900, but they like to push it up and go to 6,400 with it. So that's something to look at it as well if you want to kind of get away from things. You've got the channel width in there, but you just don't have the gain or the return loss on the dish is kind of sloped off. So that's something to look at as well, as far as applying putting the correct antenna with the correct radio.
Yeah, we don't recommend going up in those frequencies unless your government allows it. I think the second thing is we definitely don't recommend using a antenna that's been designed and the efficiency of the antenna is only for 5,100 to 5,900. We see a number of customers out of the country that are using antennas that are not designed for the frequency, and they're wondering why there's issues going on.
Yeah.
Typically, it's because the efficiency of the antenna is not very good at that frequency. So if you do plan on going those frequencies, one, make sure it's legal, and secondly, make sure you have the right product and antenna that is purposely matched for that frequency.
Okay. One more thing here. I know we've talked about radar pulses and radar. What does that look like to our radio? How many pulses do they need before they trigger DFS? Is that something that we know?
I think it's in the papers.
Well, there's a number of different radar signals. Pulse width, you have pulse repetition frequency,
Yep.
and then you also have pulse per burst for each PRF. So best thing to do is to look that up online.
Perfect.
Yeah.
Okay, guys. Well, if we don't have anything else, I guess that's all for this one.
All right.
Good.
If you have trouble with DFS, feel free to come visit Mimosa Support. Would be glad to help you out. Other than that, we'll see you next time on our next episode. Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.